Okay, so here's an example where I want to write a proof. So we're getting back to proofs here for the following information. So it says that segment BD is perpendicular to segment AC, and then segment AD is congruent to segment CD. And I want to prove that the two triangles ABD and CBD are congruent. So we can start with the given. Okay, you always write the first statement as what's given. You could write all of this as one statement and then the reason would be given, or you could break it up into two separate statements. I'm going to break it up into two separate statements. BD is perpendicular to AC, that's given, and then AD is congruent to CD, that's also given. If BD is perpendicular to AC, notice that this is a right angle, and then this is a right angle as well. So I could say that angle BDA and angle BDC are right angles. You know the reason? If you thought or you said that the reason is definition of perpendicular segments. You could also say definition of perpendicular lines. I mean, that would work, even though the sides aren't lines, they're segments. But you could even just say definition of perpendicular. And then we also have AD is congruent to DC. BD is congruent with itself. We're going to try to prove that these two triangles are congruent. The only thing that we've gone over so far on how two triangles are congruent is SAS, or side angle side. So BD, that side is in both of the triangles. So BD is congruent with itself. That's side BD. And the reason should be the reflexive property. And you could just write that. If you want to get more specific, that's fine. Reflexive property of congruence, not of equality, because we're showing that these segments are congruent. And then we have BD is congruent with itself. These two angles are right angles, therefore they have to be congruent. But then the two triangles are congruent by side angle side. Triangle ABD is congruent to triangle CBD. Again, side angle side.